Okay, so today we're going to be covering lesson 4.4, graphing a function rule. First, I'd like you to look at the mixed review there, going over some things that we did last week. So in the mixed review, it says determine if the relationship in the table is a function. If it is a function, write the equation to describe the function. So remember, last week, we talked about for every one input, there can only be one output. That is how we tell if it is a function. We could also graph the relationship to see if it forms a non-vertical line, basically. So here, if we look at x, we can see that for every x value, there is only one y value. So we can probably assume just from the data here that it is a function. So then what we need to do is write this function or write the function rule. So I'm going to start with y. And like we talked about last week, we're going to be looking for a pattern. So I'm going to look across first here and see that we're adding 2 each time. And remember, then you want to kind of ask yourself, okay, so I know that I'm adding 2 with the y, so that is going to be part of my equation. I can write that as 2x. Then I can also look here at the 0 column. When x is 0, y is 3. So that means we have to start with 3. So let's check this. So if I plugged in 1 for x, that would be 2 plus 3, which is 5. So that works. Let's try 3. So if I plug in 3 for x, I get 9. So that works. So when you're writing your equation, you want to look at the y value, and you also want to look when x is 0. Those are kind of your main points to focus on when you're writing an equation for a function, okay? Now, this next part is just kind of sharing some information with you. It's not really something you have to write on or anything like that. Just kind of listen for a second. So if we look here, it says, by finding values that satisfy a function rule, we can obviously graph the points and we can see the shape of the graph. So in this example here, what is the graph of the function rule? And they give us an equation here. So first we're going to choose any values for x and find the corresponding value of y. And to do that, it's probably better if you make a table. Most of the time, I just make a smaller table. I just make an x, y, t chart. And then you want to pick values. Generally, -2 to +2 are good values to start with, although sometimes they don't always show you the full picture of the graph, but it's a good place to start. So when we're graphing, they went from -2 to +2, and they plugged those values in for x in the equation so that we could get y. And that would give us our ordered pair, our x and our y value. And then we can then graph those ordered pairs and look at the pattern that is being created. So in this case, the graph, the points from the table indicate that we draw a straight line here. So we could say that not only is it a function, but it is a linear function. We could say that. So a lot of what we're doing today is just looking at a graphing rule and, a function rule and graphing that function rule. So here we have a table of values, and they already give us that, and then we have a graph here to graph those relationships. So we're just going to do this one. Just follow along and complete your notes. So what is the graph of this function rule? So we would take each value for x, and they've already given us those values, and plug them in. So I would plug in 1 for x, or 0, or I think that is a -1 here. It just didn't show up very well. And then a 2. And then we would take those and solve them and write our answer as an ordered pair. So if I start with -1 and I plug in -1, I solve this. So I would do the multiplication first. We've got to remember to work out the problem using order of operations. So I would multiply first, and then I would subtract the 1. So we would end up with -1.5 or -1.5. Then I do the same thing with 0. So we'd end up with just the -1. And we just keep going. Here we plug in a +1. So we would end up with a -0.5 or -0.5. And then 2, we would end up with 0, half of 2, and then -1. So now we have our ordered pairs that we can then graph on our picture here. So we have -1 and -1.5, so approximately there. Then we would start at 0 and go to -1. Then we would have 1 and -0.5. So that would be about right here, and then 2, 0, right about here. So we can see that that does make, if we were to connect these together, and make our straight line here to show that relationship. Okay, so just graphing a function rule there. Okay, moving on to example 2. Same kind of idea, but more like in a real world format, so a word problem. So the function rule is given here, and it represents the total weight in pounds of a spa that contains G gallons of water. What is a reasonable graph of the function rule given the capacity is 250 gallons? So that is obviously the most that it can hold. So again, we have our chart here. Normally, I would probably just write the ordered pair, but we'll do a couple of these. So I'm going to plug in 0 for G plus 700. So we would start with, when we have 0 gallons, we start with a weight of 700 pounds, which would make sense because they're pretty heavy. So there's our ordered pair, and we could go ahead and graph that if we wanted to, kind of just estimate about where 700 would be on our graph. Then we would plug in 50, so 8 times 50 plus the 700, and then we would continue that. So go ahead and add those to your notes. And then we would write our solutions as an ordered pair. So we end up with, I've kind of already done those calculations, so 1100, I think. And then when we have 150, we would end up with 1900. Remember, when you're working the problems out, you should be using order of operations. Multiplication before addition. And then 250, we should end up with 2700. And then we could graph those relationships there. So we already did the first one, so then we go to 50 and about where 1100 would be located. Again, we're just kind of having to estimate a little bit. Then 150 and to 1900, and 250, 2,700. So maybe about right there. And of course, that would be our stopping point because the spa can only hold up to 250 gallons. So we would stop, in this case, our graph at that location. Okay. Moving on, we kind of already discussed this. What is the weight of the spa when it's empty? Well, when you have 0 gallons, it's still going to weigh 700 pounds. Moving on to our next part of the lesson, we've got some vocabulary here to talk about. We want to look at 2 types of graphs. One is what we refer to as continuous, and the other we refer to as discrete. Now, a continuous graph is a graph that is unbroken, so we're going to label each graph as discrete or continuous. A discrete graph is a graph composed of distinct isolated points. So this 11 would be considered a continuous graph, and 12 would be considered a discrete graph because you have distinct points. I'm going to stop the video here and then I will continue the recording. I want to make sure my video is small enough that I can attach it. So continue in just a second here.